Welcome you all. In this lecture, we are going to discuss about how to compute effective stress for different ground conditions. Initially, in this lecture, we are going to discuss about what I'm trying to tell you. We are going to discuss about how to compute effective stress in case of what I say wet soil, and also in case of a dry soil. That means in these both the cases, what I'm trying to tell you, there is no water table. So water table is not there. This is, you see, this is the ground surface. We are having ground surface, and this time the soil is partially saturated. So that means no water table is there, no groundwater table. So now my interest, I want to calculate. I want to calculate effective stress at any depth h. So here you see I'm using a Z designation for depth right from 0 to H. Z is 0 at ground level. Z is equal to H at the bottom of the soil under consideration. Here you see gamma, gamma is equal to G plus SE gamma W by 1 plus E. G is given, GS is given, SR degree of saturation, E is given. So you can able to calculate gamma. Now, my interest is initially I want to calculate sigma. As you know, sigma means total stress. So here it is 0 at the top. Once you come to bottom of the layer, it will be gamma into H. Whereas here it is gamma into 0. Gamma into 0. Gamma into 0 is 0. No doubt. So stress at the ground surface is 0. Stress at any depth z is equal to h is gamma into h. This is about total stress. Now let me discuss about how to determine pore water pressure. Now there is no groundwater table within the ground. So now the pore water pressure is 0. Here gamma of water into height of the water. There is no water table. So now I'm writing 0. 0. So now what is my interest? It is very clear. I want to calculate effective stress. I want to calculate effective stress. So how to calculate effective stress? As we discussed, the strategy is effective stress principle where sigma dash is equal to sigma. You can see my previous lecture video on effective stress, introduction to effective stress principle, where you can find this sigma dash is equal to sigma minus u. Here you see I have 0 at the top, 0 regarding pore water pressure, 0 minus 0 is 0. No need to surprise. Now I am having gamma h minus 0, then we are getting gamma h. Sometimes the questioner wants to hide the information about gamma. You won't give gamma, you will give GSSE. So don't worry. Whenever in question you come across GSSE, so don't worry. You know the relation between GS, degree of saturation, and wide ratio. Gamma is equal to GS plus SE into gamma W by 1 plus. You can see my first chapter lecture video on this relation. Okay, now let us proceed. Now this is about case 1. So now I am moving to the next case. Here let me present you the next case. Here you see if your soil is dry, let me show you now. Now let me show you if your soil is dry, how we are going to do now. Here you see now, if it is a dry soil, let me select the pen now. This is a dry soil, and the soil is gamma dry. How to determine gamma dry? Here you see, in case of saturated, we will write SR1. If it is a dry soil, SR0, then gamma D is equal to undoubtedly G gamma W by 1 plus E. So sometimes I told you once again, I'm telling you once again, here you see, whenever they have given GS and E, they will not give gamma D. Don't worry, there is a relationship between GSE and gamma D. That is undoubtedly gamma D is equal to GS gamma W by 1 plus E. 1 plus E. Sometimes they may give wide ratio. Sometimes they may hide wide ratio also. They may give porosity. But where you are looking for wide ratio, you know E is equal to N by 1 minus N. We know the relationship between wide ratio and porosity. You can see in my previous lecture, n is equal to E by 1 plus E is equal to n by 1 minus n. Now here I am having gamma d because the soil is dry now. It is pure dry soil, no water table. Now let me write first. Initially, I am bothering about how to calculate total stress, and later we think about pore water pressure. So I will do minus here. This is the symbol of minus subtraction, which gives equal to this is the final effective pressure distribution diagram. This is total pressure distribution diagram. This is pore water pressure distribution diagram. This is equal to symbol for is equal to this is minus. Now you see gamma d into 0 at z0, gamma d into 0 it will be 0. Here gamma d into h, I can write z instead of h. So gamma d into h. Now gamma d h, this is about total stress at the bottom of the soil layer. Now regarding pore water pressure, we don't have water table. That's why 0. Gamma of water into height of water is 0. So gamma of water into height of water, which is also 0. Now because there is no water table here, so once there is no groundwater table, you cannot expect any pore water pressure. It is 0 right from top to bottom. Now we are getting same answer. 0 minus 0 is 0. Now gamma dh minus 0, it will be gamma dh. So this is about, but what I'm trying to tell you here, we are seeing a partially saturated soil. It has some degree of saturation. Yes sir, here degree of saturation is 0. That's why it is very interesting discussion. Here we are having only G gamma W by 1 plus E because now the ground is completely dry. So now in both the cases, fortunately, there is no water table. So that means the pore water pressure is 0 in both the cases. Hope you understood. For better understanding, for better understanding, I will do now, I will solve one numerical example on these two concepts. What I'm trying to tell you. So two concepts means the first one, here I will try to present you. Here you see, I have a ground here. Let me show you now. This is ground level. Sometimes people call ground surface. No issue. So now here you see, this is the soil. We want to calculate vertical stress at any depth z. Let me assume 4 meter. So I want to calculate vertical stress, what I call the total pressure, and also pore water pressure, and also effective stress. Let me proceed now. So now I have gamma. It is, let me tell you, it is 17 kilonewton per meter cube. Now I want to draw a pressure distribution diagram. So vertical stress distribution, total stress distribution. So undoubtedly, I will show you 0 here. What about here? Gamma into H. H is no 17 into 4. So there is no need to surprise. We have now, here you see, uh, now it is 68 kilonewton per meter square. This is about total stress. This is the entire distribution diagram. Sometimes you may be very much interested to know the stress at 1 meter. That is 1 meter. Now what is the answer? Now gamma into 1, 17 into 1, 17 kilonewton per meter square. If you want to determine the stress at 2 meter, Z is equal to 2. Now gamma into 2, 17 into 2, 17 into 2 is obviously 34 kilonewton per meter square. So now one can join these extremities. You will get this triangle. Why it is triangle? Because as the depth is increasing, stress is increasing. Here it is 0. Here it is 17. Here it is 34. Join all the ends. Now we are getting linear diagram, just like a triangular way. So this is about distribution of total stress. Total stress distribution diagram. Now, I'm very much interested to discuss about pore water pressure. So, luckily, in this particular case, the case what we are discussing here is what I'm trying to tell you. It is a just partially saturated soil. So, where it is very interesting to discuss. There is no water table, no groundwater table. So one can easily understand there is no groundwater table. So now let us proceed now. Minus for water pressure, which is 0. Gamma of water into height of, because no water table, so the height of water is 0. Gamma of water into 0, then it becomes 0. I will write here 0. People may mistaken. Now here it is 0. Gamma of water into height, because there is no water table. Again, I'm telling you, no groundwater table. So height of water is 0. If we insert piezometer, it shows 0. So now head of the water is 0. Now is equal to. So altogether, I'm getting the answer now. This is pore water pressure distribution diagram. My interest is to calculate effective stress sigma dash is equal to sigma minus u. Now it is the time to draw the final diagram, actual pressure distribution diagram that I am trying to call effective pressure, also called intergranular pressure. 0 minus 0, it becomes 0. I will write here 0 minus 0. Now it is very interesting to write gamma into h minus 0, that I'm trying to call here 68 minus 0. Ultimately answer is 68 kilonewton per meter square, because you know that here gamma is in kilonewton per meter cube. You are multiplying with meter. Ultimately you are getting the units for pressure, or we use it to call here stress, kilonewton per meter square. This is about partially saturated soil. So in the similarly, with the same enthusiasm, let us discuss what is going to be happen if your ground is dry. Let me show you. It is dry soil. Here what I'm trying to show you, it has 16 kilonewton per meter cube for understanding. I'm assuming that the dry unit weight of the soil is 16 kilonewton per meter cube. Now, let me tell you, I want to determine the what effective stress at a depth h is equal to 4 meter. Now, let me proceed now. No water table. Now, this is dry soil. The case is very interesting. That is the present case. Now here you see, anybody ready to tell me now? Here you see we have gamma d into h. Here it is gamma d into 0, because depth is 0. Here at z is 0. Here z is equal to h. Now let me tell you now what I'm getting now at the base of the soil. What I say here, 16 into height is 4. So I can easily write now 16 into 4, 40 plus 24. So it will be 64 kilonewton per meter square. This is about total stress distribution diagram. Minus, somebody is very much interested to know pore water pressure. No water table is there. No groundwater table is there. So undoubtedly now we are having more confidence about drawing pore water pressure distribution diagram. It is 0, 0. What I'm trying to tell you, gamma of water into 0, because head of the water is 0. I'm trying to write here head of the water is 0. So here also gamma of water into height of water. Let me tell you, gamma of water into 0, because no water table is there. Head of water is 0, literally 0. Now it is 0. Now what is the final answer? This is pore water pressure distribution diagram. But my interest is very clear. Draw, I want to draw effective stress distribution diagram right from top to bottom. Top to bottom. 0 here. Why I'm writing 0? As you know, 0 minus 0 is 0. Now here it is at the base, gamma dh minus 0, that we already calculated, 64 minus 0, which is equal to 64. This is sigma diagram. This is pore water pressure distribution diagram. Pore water pressure distribution is also called neutral pressure diagram. Now this is effective stress, which is also called intergranular pressure. This is the original stress acting on the soil mass. Thank you all.